Hello everyone, this is a short introduction about myself. My name is Dr. Anita Dani. I have a PhD in mathematics education. I am a fellow of Higher Education Academy, United Kingdom. I have 25 years of teaching experience in multicultural environment. Here is the link to my LinkedIn profile. I completed my master's in mathematics from the Savitribai Phule University in India. Then from 2000 to 2023, I worked as a senior lecturer. I taught undergraduate courses for computer science major, including mathematics, statistics, and programming. Then I completed my PhD in mathematics education from the British University in Dubai. This is also in the United Arab Emirates. In 2023, I moved to Canada to be with my family. Since 2023, I'm working as a volunteer for Statistics Without Borders. So I'm going to present a lecture on one of the topics in statistics. Thank you very much. Hello everyone. This is last chapter of the syllabus developed for African Institute for Professional Development. The chapter is Regression. It has two parts. Part 1 correlation, part 2 regression. Part 1, overview of part 1. We are going to see what is correlation, basic idea and assumptions. We will understand graphs and their interpretation in real life applications. Understand the correlation coefficient. Use technology to calculate it. Then difference between correlation and causation. Let us recall some prerequisite knowledge which will be useful in understanding today's lesson. You have to remember straight line graphs and non-linear graphs. Then the types of variables, discrete, continuous or categorical. Categorical, same as qualitative. What has been covered so far is the analysis of one variable. This is the next step in which we are going to study analysis of two or more variables together. Motivation. Why should we study correlation? In some real life applications, the objective of statistical analysis is to study changes in two or more variables. Two variables change their values in tandem with each other. In statistical terms, they correlate with each other. So even though we have said two or more variables, scope of this lesson is restricted to study of two continuous variables. Let's look at some real life examples. You will see some part of this, each example is written in bold. So they represent variables. When the time spent doing physical activities increases, the number of calories burned also increases. So these are two variables, time spent and number of calories. Second example, if the daily calories intake increases, the body weight also increases. As the age of a car increases, its price decreases. As the hours of safety training provided to employees increases, the number of on-job injuries decreases. Now let us notice the pairs of variables and the direction of change in each of the above examples. As we noted before, we have seen two variables, time spent and number of calories. Second example, daily calories intake and body weight. In these two examples, when one variable increases, the other also increases. So the two variables change in the same direction. Daily calories intake increases, body weight increases. Let's look at next two examples. Age of a car increases, the price decreases. Now this change is not same as the changes in these two examples. So what we notice here, the two variables change in the direction opposite to each other. So one is increasing, the other is decreasing. So when we see the variables change in the same direction, we say a positive correlation is observed between the pairs of variables, which we have seen in the first two examples. Whereas in the last two examples, the correlation between the variables is negative. They are changing in the direction opposite to each other. So a correlation can be positive or negative. There are two ways to examine correlation between two variables. Our purpose will be to examine if the two variables really change together or not. So one way is to plot a diagram, the scatter plot, visual representation, and the other is calculate correlation coefficient. The first one is slightly approximate estimation, whereas the second one, being analytic method, it is more precise. Let's take example one by one. Let's see how to do a scatter plot and how to interpret the information from it. So we have to take one variable on x-axis, which is independent variable. We are going to talk about independent and dependent variables later on. At this point, we just note that we take one variable on x-axis and the other variable on y-axis. So for each data set, the ordered pair x and y are plotted on a two-dimensional grid, a grid of x and y axis. So we have a data. We have information about 6 companies. This is just for information. This variable will not be part of any analysis. The first variable is number of cars manufactured. These are in 10,000s. And the second variable is revenue, which is in billions. So company A manufactured 63, multiply 10,000 number of cars, and the revenue was 7 billion. And so on for each company. So to understand whether there is correlation between these two variables, we draw a graph. We take each pair x and y. You can see first pair 63 and 7. You can see it here, 63 and 7. Second pair 29 and 3.9, which is here. And so on for all 6 companies. If you notice, these are just plotted as points. They are not joined with each other. They are scattered. That's why the name is given as scatter plot. We can see that the points are not on the same line. But still we can observe a linear pattern. As the x values decrease from top to bottom, y values also decrease from top to bottom. 63 decreasing to 29 to 20.8, similarly 7 decreasing to 3.9, 2.1, and so on. So we are using the same word, decrease, decrease. So they change together in the same direction. So this is a positive linear correlation. Looking at the pattern of the scatter plot, type of correlation is identified in 2 broad categories, linear and non-linear. These are examples of linear correlation. You can see a straight line graph, a pattern of straight line graph. This is linear correlation. But still, we observe that there is a difference. This is upward graph with positive gradient. So graph A is positive linear correlation. But this one, it's a downward graph, negative gradient. So negative gradient or slope. So this is negative linear correlation. And a scatter plot which does not look like this, something like this. First part it is going downward, then going upward. It's very much different than the linear pattern. So this is non-linear correlation. So we are going to restrict our scope of this lesson to study linear correlation. Let us look at some different examples of scatter plots. This is graph A. You can see all points are on a straight line. It's a perfect correlation. Sometimes we don't get all points on the same line, but still most of them are close to a line and they're close to each other. Compare it with this one. These points are more scattered. They're not very close to each other, just like in graph B. All graphs exhibit a positive linear correlation. Their patterns are not exactly same. So to distinguish them in detail, additional information is provided about strength of the correlation. The direction is given by positive or negative. Now we need extra information about strength of the correlation. This is very strong positive. All points are on a straight line. Graph B is strong but not as strong as this. So we just say it is strong positive. Whereas graph C, it is strong but not as strong as graph B or A. So it is moderately strong. We are saying that it is moderately strong because the points are close to each other but not very close to each other like previous two examples. We can see similar pattern in the negative correlation as well. This is perfect negative. It's a downward line. All points are on the same line. This is strong negative. Not all points on the same line, but still close to each other, and the pattern is downward. Points are not very close to each other, so moderately strong negative correlation. So whenever we describe correlation, we specify the direction as positive or negative and strength as strong, moderately strong. Sometimes we also see a weak correlation. We have seen the graphical method. Now let us see the second method, the correlation coefficient. Pearson coefficient of correlation is the statistic that we are going to calculate. It indicates the strength and the direction of correlation between two variables x and y. It is calculated using the formula. You try to understand the formula. We multiply x and y. We take product of their terms, then take the sum of their products. Here we take sum of x, sum of y, and then we take their product. So apparently this formula is a bit complex, but do not worry, we are going to use technology to calculate it. What's the meaning of this R? What are the possible values? So range of R values, the smallest can be -1 and the maximum can be +1. You can have values in between. You can even see sometimes R is 0, which means no linear relationship. As you go towards -1 on the left side, the strength increases, but it is negative correlation. As you go to the right of 0, the strength increases and it is positive correlation. It is recommended to use any statistical calculator or software programs such as Excel or SPSS. So the steps of calculating R using Excel are shown on slide 14. We just look at rule of thumb for interpreting the size of a correlation coefficient. These are guidelines. This table has been adopted from a paper. You can see the title of the paper in the references. You can see the size of correlation, the range, and what is the interpretation. So when you calculate R and if the values are between 0.9 to 1.0, you can say there is very high positive correlation. Similarly, if it is between 0.9 and negative, if it is between negative 0.9 and negative 1, it is still very high but negative correlation. The strength decreases for the next range, 0.7 to 0.9, high or strong positive, 0.5 to 0.7, moderate or somewhat positive, strong correlation. Between 0.3 to 0.5, low positive correlation. Similarly, you can interpret for negative values. If it is less than 0.3, it is very weak or negligible correlation. These cutoff points are arbitrary and inconsistent, should be used judiciously. While most researchers would probably agree that a coefficient of less than 0.1 in this range indicates a negligible and greater than 0.9 indicates a very strong relationship. Values in between are disputable. What is considered strong can depend on the context and the field of study. For example, in biology, much smaller values might indicate strong correlation. You may refer to another article. You can see the name in the references list. Let's see how we do correlation analysis using Excel. So this is an example data set. We have calories as one variable, cholesterol level as another variable. So the first ordered pair is 390 and 43 and so on. So if you want to use Excel, open Excel and enter the data as shown here. Put headers for each column, calories and cholesterol, and enter the numbers one by one. After you enter data, go back to the given data set and check if you entered them correctly. 393 paired with 43, 535 paired with 45 and so on. Go to the cell A10 and type the formula. As you know in Excel, formula always begins with equal sign. The formula for calculating correlation coefficient has a short name, CORREL. Then provide the range of X values A2 to A8, Y values B2 to B8. Excel will do the calculations for you and you will see the answer like this one. It is recommended to round this number to 4 decimal places, or you can round it to 2 decimal places depending on the requirement. Then comes the part of interpretation. It is above 0.7. It is positive. So our interpretation will be there is strong positive correlation. It means when calories increase, the cholesterol level also increases. How to draw a scatter plot for the same data? You have already entered the data. Select two columns together from cells A1 to B8. On the top you have Insert tab. Click on Insert. When you press Insert, you will see the templates for graphs. You need to choose this template for scatter plot. That's it. The scatter plot is drawn here. Here I have shown a scatter plot after adjusting the scales and adding titles. Looking at the values, I don't need values less than 200 for X, so I can start from 200 on X-axis. I don't need values less than 30 for cholesterol, so on Y-axis I can start from 30. This is just for better representation. Here is another example. X values, Y values. I have done this scatter plot. I have given you the calculated value of R. Looking at the graph, we can see the data points are scattered away, not showing a clear increasing or decreasing pattern. We can say there is no correlation or very negligible correlation. Looking at the value of R, it is less than 0.1. So this is confirmed. The scatter plot shows very weak or negligible correlation. This is something for you to check your understanding. First question, you have 4 values for R. You have to decide out of these which one represents a strong correlation. Next question, based on scatter plot, you need to decide which one represents a weak negative correlation. So keep your answers ready and check them on the next slide. (0.82), even though it has negative sign, it is very close to -1. This is not very close as compared to this. This is very negligible, less than 0.1. This is somewhat weak correlation. This is somewhat strong correlation, but this is strong negative correlation. For this graph, this is upward trend. This is certainly not negative correlation. So this is not one of the correct possible answers. Compare graph B and graph C. You can clearly see a decreasing pattern here. Whereas in graph B, you're not sure. Sometimes you see a -1, you see +1, and the points are not very close to each other. So this graph B represents weak negative correlation. Now it is your turn to draw a scatter plot and calculate correlation coefficient. For any question, your first step is to understand the data set. In this example, you can see a table. The description of the problem is like this. A study was conducted with vegetarians to see whether the number of grams of protein each ate per day was related to diastolic blood pressure. The data are given here. So one variable is grams protein intake and the second variable is blood pressure levels. So you can follow the steps. You can follow the steps as given below. Copy this data in Excel in the cells A1 to A10. This is your first step. Put the column headers in A1, B1, and then the numbers starting from A2 to B10. After that, you have to draw a scatter plot. You can revise the steps from the previous slide. You have to select both columns together, click on Insert and choose the template for scatter plot. You have to calculate the correlation coefficient R using the formula CORREL. Don't forget to put equal sign before writing the formula. On the next slide, we will see the graph and interpretation of this data. The graph is shown here. The value of correlation which is calculated is shown here. So let us write down the observations. From the graph, we can see the points are close to each other. There is a pattern of a straight line with a positive gradient. So it's upward graph. The observation aligns with the calculated value of the correlation coefficient. R is positive, 0.9059, which is very close to +1, suggesting a strong positive correlation. So how do we interpret this in the simple words? When we have to write conclusion, we relate this information with the variables in the data set. We can write it, higher intake of protein implies higher diastolic blood pressure levels. We have to make some important notes here. This observation and interpretation is applicable to this sample data only. Same correlation may not be observed on a different sample. So we have understood how to do the correlation analysis using Excel. We have to understand correlation and causation. These two are different terms. So let us understand limitations of correlation analysis. If you look at the data set, you have values starting from 4 to 10.5, but the value 7 is missing. So there is no data about a person whose protein intake is 7 grams. So in this example, it is not possible to predict blood pressure levels of a person whose protein intake is 7 grams. That's a limitation of correlation analysis. We have only established correlation and it is not causation. Correlation analysis is the first step in bivariate analysis. It only indicates that the two variables change in tandem. Study of causation involves studying effect of change in X on change in Y. So if we go back to this example, where we notice that the value 7 is missing from the data set, in order to predict Y, which represents blood pressure levels, from X, which represents the protein intake, we need to build a predictive model which is achieved by performing regression analysis. So in causation, we may want to examine if changes in Y are caused by changes in X. Equivalently, we say X is the cause and Y is the effect. From the scatter plot and correlation coefficient, the strength and the direction of relationship that exists between two variables, X and Y, can be discovered. But it is not contributing to examination of cause and effect. What it means, two variables X and Y may correlate with each other. From their correlation, we cannot claim that changes in Y are only due to changes in X. The observed correlation can be due to a chance or maybe a third variable which is causing changes in both X and Y, but that variable is not being observed. So studying cause and effect is part of linear regression. It is done for the study of cause and effect. A researcher has to identify two types of variables. Independent variable, which is changing independently or can be manipulated by the researcher, and the dependent variable, which changes as an effect of change in X. Significance of the correlation coefficient should be examined to confirm that the observed correlation is not due to chance. After these two steps, first identify independent and dependent variables, check correlation and its significance. Its significance will establish that it is not observed due to chance. After these two steps, a linear equation should be built using the observed values of X and Y. This is achieved by performing regression analysis. So part 2 is regression. In this part, we will see simple linear regression, how to create and interpret a line of best fit. We will use technology to create it. Apply that equation in real-life applications. Recognize the assumptions and how to check them, and limitations of using regression analysis. We are continuing with the examples that we saw on the previous slide. We had seen two variables, time spent doing physical activities. The values of this variable change independently. A person can decide how much time to spend on activities. The change in the values of number of calories burned will occur as a result of the change in this variable. So in this example, time spent doing physical activities is the independent variable and number of calories burned is the dependent variable. Independent variable is denoted by X and dependent variable is denoted by Y. If you remember, that's why we had taken variable on X-axis, X variable, and the variable Y on Y-axis. I'm going to present the remaining three examples, and you will have to identify dependent and independent variables. So here are the examples. If the daily calories intake increases, the body weight also increases. So identify which one is independent, which one is dependent. As the age of a car increases, its price decreases. As the hours of safety training provided to employees increases, the number of on-job injuries decreases. If you have written your answers, check them now. Independent variable in the first example is the daily calories intake. Body weight will depend on it. Daily calories intake is something that can be manipulated. The person can decide how many calories to take every day. Age of a car, it changes on its own. Price will depend on age of a car. So price is dependent. Company can decide how many hours of safety training to be provided. But the number of on-job injuries will depend on it. So that's the independent variable. Regression analysis is an example of dependence analysis. In regression analysis, an algebraic model is derived to obtain prediction of the dependent variable using the values of the independent variable. So the model links the variable X with variable Y through some algebraic expression. If we have observed linear correlation between dependent and independent variables, it will lead to the development of a linear algebraic model. This is simple linear regression. We will try to understand the concept of line of best fit. Refer to the scatter plot which we have done before. If you try to draw lines, there are several possible lines. There is no single line which will pass through all data points. If we draw a line, some points may be at a distance from the line. Some points may be above the line, some may be below the line. So we have to draw a line which will minimize the total distance between the points and the line. And that will be the line of best fit. And that is regression line as well. So look at the example below. So the line of best fit will look like this one. You can see the points are not on the line. Some are above, some are below. But if you try to take the total of the distances between the point and the line, that total distance is minimum. So regression line is the line of best fit for the observed values of x and y. Equation of a straight line is y is equal to a plus bx. So the number with x is the slope or gradient of the line. And the number a alone is the y-intercept of the line. So when we do regression analysis, our aim is to determine values of a and b. So values of a and b for a regression line are calculated using the formula. This equation can be determined using Excel. So what is the formula? It is this one. So you calculate A, calculate B. A is the intercept and B is the slope or gradient. As we did correlation using Excel, we continue using Excel to do the regression analysis as well. On this slide, you will see steps of plotting a scatter plot with regression line using Excel. You have learned how to draw the scatter plot. So first draw the scatter plot and then follow the below steps. Select the scatter plot. This is your step 1. When you select the chart, a tab will appear on top which is Chart Tools. Click on that tool. You will see option for choosing a layout for the graph. So your step number 3 is to click on Quick Layout button. It will show you different layouts in the drop-down menu. To show the regression line, you have to select the layout number 9. So step 4, just click on this layout. This is how your graph will change. It's the same scatter plot, but the line of best fit is drawn. You also see some equation here and some number as r square. So the equation y equals 0.0681 times x plus 22.765 is the equation of the line of best fit or the regression line. The slope is 0.0681 and the y-intercept is 22.765. R square is the square root of correlation coefficient. So for using this value, we can calculate correlation coefficient by taking positive square root of R square. and that will be 0.72519. This R square is the coefficient of determination. Normally it is written in percentages. So the same number, it will be written as 52.59%. As we know, the square root can be positive or negative. So you have to first check, should you take positive square root or negative square root. In this case, the slope or the gradient of this line is positive. So we take positive square root. But if you observe that the slope of the line is negative, then you take the negative square root of this number. How do we apply this regression model? Look at this example, calories and cholesterol. If you see, you have numbers representing calories, but the calories 600, this value is missing from X dataset. So you have to predict Y when X is 600 calories. You will see here, instead of writing Y, it is written as Y dash because it's the predicted value. It's not observed value. So first you have to check something. You have to look at the minimum and the maximum value of X. So the minimum is 300, maximum is 720. So before you proceed, check first. The minimum value is 300, maximum 720, and we are going to estimate Y when X is 600. So it is in the interval from 300 to 720. So X is in the interval minimum to maximum. This type of prediction where we interpolate between the minimum and the maximum. This is interpolation. So if you are checking first and you find that whatever value you are going to do the prediction for is in the interval minimum to maximum, your prediction is reliable. There are two ways to do this. You can use the graph, for which you locate 600 on x-axis, draw a line to the regression line, vertical line. From the line, go to y-axis. So this will be the predicted value. You can also use the equation. You have seen this equation before. In this equation, in place of x, you write 600 and calculate. You will see the answer as 63.6, which is somewhat same answer that you obtained from the graph. If you are trying to do prediction for y when x is outside this range, for example, you try to predict for 250 or 750, this prediction will not be reliable. Let's understand in detail what is coefficient of determination. It is a measure of the variation of the dependent variable that is explained by the regression line and the independent variable. The symbol for the coefficient of determination is capital R square. It helps to describe how well a regression line fits. It is an overall measure of the accuracy of the regression model. Its values range from 0 to 1. The correlation coefficient ranges from -1 to 1, but now it is being squared, so it will not have any negative value. A value close to 0 indicates that the regression line does not fit the set of data points. A value close to 1 indicates that the regression line fits well the set of data points. It has a stronger predictive power. So let's see interpretation of R square for the same example. First we write it as percentage. 0.5259. We are taking it from here. Approximate percentage will be 53%. It means 53% of variation in Y is explained by variation in X. Using this value, we calculate coefficient of non-determination. It is 1 minus R square. In this case, it is going to be 47%. It means 47% of variation in Y cannot be explained by variation in X. There can be other variables responsible for this variation. It's your turn to answer two questions. You have some values of R. Out of these values, which correlation coefficient represents a good fit of regression line? For the second question, the regression equation is given. You have to do prediction for two values. At the same time, you have to decide is the prediction reliable or not. Keep your answers ready. You will see the answers on the next slide. For the first question, you must first calculate R square. Whichever number is very close to 1, it represents a good fit. So your answer should be R is equal to negative 0.82. To check the reliability of prediction, what is the minimum value of X? It's 4 and the maximum 10.5. So you are predicting for 7. It is between the minimum and maximum value. So whatever is your prediction is reliable. And for determining value of Y or predicting value of Y, in this equation, substitute X is equal to 7. So your expected answer is 83.7. You can do the same substitution for the next value, X is equal to 11. You can always calculate value for Y using the model, but because 11 is not within the range of minimum to maximum, this prediction is not reliable. So we come to the end of this lesson. Summarize by writing the key takeaways. Correlation describes association between two variables. Correlation coefficient R is between -1 and 1. Correlation coefficient describes strength and direction of correlation. Study of cause and effect is causation. It is not explained by correlation. Correlation does not explain causation. For causation, we have to do a line of regression. It is the line of best fit and its equation can be used for prediction. Here are some references. Thank you very much.